Today, folks, we are going to look at how to factor polynomials by factor by grouping. When you're all done today, you're going to be able to do a problem much like what is seen here in the do. Okay, our wicker, know and do. The wicker, know, is the meaning of the word grouping. Okay, and our do, well, let's just jump to our essential question here. Our essential question for today is, what is factor by grouping? Now, let me take a second and let's think of grouping. In life, there are certain ways we group things. For example, Facebook. Facebook is a way of grouping people with commonalities. Okay? Likewise, today we are going to take a look at polynomials, and I'm going to group certain parts of this polynomial according to commonalities. Okay, well, let's go ahead and begin the instructional material. Okay, in this polynomial, I want you to take a look, well, just glance at this polynomial. And what do you see? For example, look here and look here. Do you see something common in both terms? Well, guys, just so happens, sometimes the greatest common factor is a binomial, okay? And that's what we see here. We have a binomial that is common. Well, what can we do with this situation when we have a binomial that is common? Well, let's go talk about that. If we have a binomial that's common to each of these terms, and here I turned it red here, I want you to notice what happens. We can take this binomial and we can factor the binomial out. So if I take that binomial and I pull it out front, okay, I take that binomial and I pull it out front, I'm left here with x plus a 2. And what's left inside if I take this away? For example, let me go ahead and just cover this up for a second. Let's say I were to pull this binomial out, and this here is gone. Okay, so that there disappears. Okay, and not only that, but this here disappears because I pull it out front. Well, if that happens, then what's left? So I pull this out front, like I did right here. I pulled it out front, and then what's left? Well, I'm left with the 5 plus a 3x. That is called factoring by grouping. Now, sometimes our problem looks like this. I don't see anything grouped together. Okay, so what can we do here? How do I handle this? Would it be possible maybe to take the first two and group them in some fashion like this? And then maybe factor something out? I don't know. Well, I tell you what, let's go find out. Okay, the first thing that we're going to do is we're going to group the first two and the last two together. Now, this doesn't always work. Sometimes we have to rotate the terms around. But let's start with this one by grouping the first two and the last two. Okay, so it's going to look something like this. Now, take a look at this term. Take a look at this term and ask yourself, is there something common that comes out of those two terms? For example, 6, 4, they're both even, so I can pull out a 2. I see an h to the fourth, h to the third. Looks like they both have an h to the third in common. So I'm going to pull out a 2h to the third. Okay, so it's going to look like this. Now, let's look at these next two. What comes out of here and here? Well, I can factor out a 4, it looks like. And if I factor out a 4, we'll pull that 4 out. If I factor a 4 out, then what's left? Well, a 3h minus a 2. Now, this is what I want you to see. See this here? See this here? Those common binomial factors now. We have factored by grouping in such a way that I now have common binomial factors. Now I can factor out that common binomial factor. So I'm going to factor it out. Alright, so let me uncover this, and it shows it all highlighted. Okay, so here we see the common binomial factors. Now I'm going to take that, we're going to factor that out, which means I am going to pull out that 3h minus 2. So I'm going to pull that here out, and then what is left? Well, let's think about this a second. If I were to factor it, that 3h minus 2 out, I wouldn't have those any longer. So what's it left? Well, it looks like I'm going to be left with 2h to the third plus a 4. So I'm just going to bring that down, and we're going to say 2h to the third plus a 4. And there is my factor by the method, factor by grouping. All right, now let's go check it. If I take this here and I multiply the 3h minus 2 times the 2h cubed plus a 4, this is what we're going to see. Okay, so we're going to distribute that in, and it's going to look like this. Now we're going to multiply those together, add like terms, and it's going to come down. And now let's look. Is that what we originally had? Well, let's look back. Is it? And it is. So that tells us that this right here is the factors of our original polynomial. Okay, let's do another one. All right, so the first thing I'm going to do is I'm going to group the first two together and the next two together. Let's see, that yellow doesn't show up very well, so let's change that color to red. Okay, so again, we're going to group the first two and the last two. Those are always the first two that I try. Then we're going to compare here what's common. Well, I can factor out a 5. Looks like I have y to the third. So factor that out, and that leaves me with a y minus, and right here, what's left if I factor out a 5y to the third? Looks like there's a 3. Okay, so now let's do the next one. Okay, so if I go to the next one here, let me change my color to blue. So let's see. Here I have a y squared minus 3y. I can factor out a y. So I'm going to factor out a y. And what's left here? Well, it looks like it's going to be a y. And what's left here? Minus 3. All right, now looking at that, looks like I have a y minus 3 as a common binomial factor. So I can factor out that y minus 3. And if I factor out that y minus 3, what do I have left? Well, if need be, kind of cover up some of these, So right here, this will be gone. That'll be gone. So what's left? Well, looks like all that's left is going to be 5y to the third plus y. All right, now, when you're done with that, once in a while you can look at this and you can see, you know what? I see I can factor it further. Okay, remember back when we factored completely? Well, guys, this is one of those situations. So when you're all done factoring by grouping, look at each factor and ask yourself, will anything factor further? Well, you know what? It looks like I can factor a y out of there. So I'm going to go ahead and do that. I'm going to factor a y out of there. So let's see, and I'm going to pull that y all the way out front. So I'm left with y minus 3, just copy that down. And if I factor a y out of there, I'm left with a 5y squared. Factor a y out of there, I'm left with a plus 1. And that looks good. I'm factored completely. In some situations, we're going to look at something like this. Okay, now I want you to see something if we look at something like that. Notice this here is 5 minus y, and this is x minus 5. Notice the difference. This 5 is positive, that 5 is negative. This x is negative, that x is positive. Okay, so here's what I want. Here's what we're going to play with here. I'm going to show you that if we took this right here, I'm going to put a negative 1 out there, and we're going to distribute that negative 1 inside. Let's see what happens. Okay, so I'm going to get a negative x plus 5. Okay, all right, so a negative x plus 5. All right, now, in noticing this negative x plus 5, okay, notice here, negative x plus 5. That looks like it's the same. It is. Yep. So whoops. So that tells me right there that this right here is the same as this with a -1 out front of there. Likewise, this would be the same as this with a -1 out here. Okay. All right, so I wanted you to see that because we're going to use that technique here on this next problem. Okay, let's look what I've written out here on this problem for you. First of all, we group the first two and we group the last two. And then we looked here and asked ourselves, what's common between these two? Well, there is a 2x squared. So I factored out a 2x squared. Okay, now, what's that leave me with here? Well, an x. What's that leave me with right here? Well, let's see. If I factor 2 out of there, I left with a -6. I factored both x squareds out of there, so just x minus 6. Now, over here, what's common there? Well, I can factor out a 3. So I bring out that 3, and that leaves me with a 6 and a -x right there. Now, this is a situation we were talking about on the previous slide. If I were to put a negative out here, I could make this x minus 6. That's what I'm going to do. So I'm going to make this 3 a negative, as I showed right there, making this x minus 6. Now, compare these two. What's common to these two terms? Well, x minus 6. So I'm going to factor that. I'm going to take this here, factor it out, pull it out there, and then what is left? Well, just remember here, you know, if I cover these up right here and right here, that gives us what left over? Well, a 2x squared minus a 3. Okay, so we pulled this x minus 6 out, leaving us with 2x squared minus 3. Now, take a look at each of these. Will this factor further? X minus 6. Nope, sure won't. Is there anything common here between the 2x squared minus 3? Any other common factors? Nope, sure isn't. So what does that mean? Well, that means I factored completely. Okay guys, here's our assignment for next class period. What I'm going to be doing is I'll be giving you a handout in class next time, and you'll be doing these questions. Alright guys, well, I'll see you in class.